Hi, welcome to my channel. In the previous video, we discussed about the MNST dataset. MNST dataset. It contains 70,000 handwritten images, digits. Okay, and these digits are classified to two parts, divided two parts. One is for the training purpose and testing purpose. So here the training contains 60,000 handwritten digits randomly assigned and 10,000 handwritten digits. So between the 0 to 9 classes. Okay, and on this data set we are going to apply one model. That model is called as a binary classifier. That means training a binary classifier. On the given data set, that means on the MNS data set, we are applying the one model. That model is called as a binary classifier. That means here we are applying we are dividing data into two parts based on our binary classifier. The class labels are here. The digit the given image is digit 5 or not 5. Okay, so not 5 contains whether it may be 0, 1, 2, 3, 4, 6, 7, 8 and 9. So they are the different class labels for the not 5, and whereas for the digit class 5, it contains only 5 digits. Okay, so now whether the binary classifier working properly or not, we are going to find out the performance of our model. That model is so based on some performance metrics like measuring accuracy using the cross validation. So based on the accuracy, we are finding the performance of the binary classifier. So here not only the accuracy is the more performance measure, there are different types of performance measures are there. So here, for example, confusion matrix, and based on this confusion matrix, we are going to find out the precision, recall, F1 score, and precision recall, trade-off, and also we are finding the ROC curve and AUC curve, curves. Okay, so they are the different performance measures for the binary classifier. Later we discuss about the multi-class classification problem. Multi-class classification. Okay, and later we discuss about the error analysis, and also we discussed about multilabel classification. Please watch through the previous videos to understand about topics. In the present video, we are going to discuss about the multi-output classification. So in the coming session, we are going to discuss about what is the meaning of multi-output classification. Okay. Now, so here the multi-output multi-class classification. Simply this is also called as a multi-output classification. So it is simply a generalization of multi-label classification. It is simply a generalization of multi-label classification, where each label contains multi classes. That is, it can have more than 2 possible values. It contains more than 2 possible values. Simply it is called as a multi-output classification. So here we are going to build a system that removes the noise from the images. So for example, we are going to take an example. In that we are going to remove the noise from the images. Okay, it will take a input as a nice digit images. Okay, So for example, here the handwritten digit image is 5 is there or 4 is there, contains different noises. Okay. Now we are going to remove the noise from the corresponding image. Okay. Now it will output a clean digit image. Now our aim is we are giving the input as a noise input image. Okay. Now we are going to perform the from removing the noise. After removing the noise, we are going to clean the output image 5. So it represents an array of pixel intensities. Now the pixel intensity nothing but here our image is in the form contains different intensities like between the 0 to 255. So 0 means black, 0 means black, and 255 means white pixel, white value. Okay. So here our dataset contains MNST images, MNST handwritten digits. So now each day we print in the form of a 0 to 255 pixel values. Now the classifier output is a multilabel. That means one label for each pixel. So here, for example, the pixel, the image contains here in the form of a pixel. Okay, each pixel contains so there is one 4x4 matrix. Here this small part is called as a pixel. This pixel contains any value between the 0 to 255. Okay, this is called a multi-label. Okay, multi-label classification, and each label can have multiple values. Each label can have multiple values. So here the each label it contains the different values between the 0 to 255. Okay, so the pixel intensities ranges from the 0 to 255. So it is an example of the multi-output classification system. So multi-output systems are not limited to classification tasks. Okay, you can have a system that output the multi-labels per instance, including both the class labels and as well as the value labels. So creating the training and test sets by taking the MNST images and adding the noise to their pixel intensities with NumPy randint function. So here the MNST dataset contains 70,000 images. These 70,000 images divided into for the training and testing purpose. Okay. So here the training contains 60,000 handwritten images, 10,000 handwritten images for the testing purpose. Each image contains 784 features. 784 that features are there. Okay, 783. That means totally 784 features are there. Okay, these 784 features are represented between the 0 to 255 values, and we are going to add some noise to these pixel values. Okay, with the help of a randint function. Okay, now the target images will be original images. Our aim is we are going to get the original image, and here we are going to add the noise in the form of a randomly. Okay, so we are going to add creating a noise with the help of np.random.randint between the 0 to 100. The length of the X train, that means for each and every images in that X train data, each image contains 784 features. So 784 features. Okay, that is 0 to 783 features. So for each feature, we are going to add some noise. So x underscore train underscore modified equal to x underscore train and plus noise. That means for the original image, for the original training data, we are going to add the noise between the 0 to 100. Okay. Now noise equal to np.random.randint 0, 100, length of the x test, 784. That means for the testing data also we are going to have the noise data. Okay, so x underscore test underscore modification equal to x underscore test original test data plus we are going to add the nice data. Now we are going to modify the data where y underscore train underscore modification equal to x underscore train. That means here we are going to we are y underscore train underscore modification is equal to x underscore train. That is the original training data. Original training data. Now we are going to look at these images. This is the original and this is the nice image data. Nice image data. Now that is converted into original image data. Original image data. That means you are removing the noise from the nice image data. Okay. After removing the noise we are going to get the original images. And so here the left side of it contains the noisy input image and the right contains the cleaned target image. So here it does not contain any noise. Does not contain any noise. Okay, it removes the noise. And now we are going to see the trainer classifier. That means on the training on the noise data, we are going to perform some classifier to remove the noise. Okay, so here we are going to use the model called as a KNN dot underscore classification. This is KNN classifier. On this classifier, we are going to train with the fit function used for the training. Okay, for the training, we are providing the x train data and the y train data. That means x underscore y underscore x underscore train underscore modification data and y underscore train underscore modification data. Okay, that means x label and that means x features are going to provide and corresponding class labels also we are going to provide. Okay, then clean underscore digit. How we are going to get the clean digit? This is a clean digit. Okay, clean digit. How we are going to get clean digit now? So KNN dot classifier or for the model we are going to predict based on the predict function. Okay, KNN dot underscore classification dot predict function. Further, we are providing the x underscore test underscore modification. Okay, x underscore test underscore modification for the given image. Okay, some index value. So for any give, suppose it is a index is 4 or 3 like that. We are going to call index value. So now plot underscore digit. So for the we are displaying the clean underscore digit function. So like that we are going to find out the multi-output class classification problem. Thank you for watching our video. Please subscribe my channel. Thank you.